All right, today we're going to talk about the volume of prisms and pyramids. And recall that a prism has two parallel bases, and the sides are all rectangles. And a pyramid, a little different, only has one base and has triangle sides. Also recall that we said if it's regular, that means that the bases are regular, not necessarily the sides. So the bases have the same measure of the angles and the sides are all the same length. But remember, our lateral sides, our rectangle or our triangles, may or may not be regular. We call it a regular prism or pyramid if it's the base that's regular. Okay, and then also recall from our first day of class, we talked about volume being the amount of cubes or cubic units that fit inside of a three-dimensional shape. And we talked about the size of cube matters. Remember, we had a teeny tiny 1 centimeter cube, and then we had a giant cube. So the size of the cube will depend on our volume quantity at the end, and we have to make sense of that. So we're going to start with a prism today. So the first thing we need to do when we're doing this is to identify what kind of prism it is. Remember, those are the parallel bases, right? And so you can see in our box on the side there, we have all sorts of different kinds. We had triangular prisms, we had hexagonal prisms. The two sides that are parallel are going to be the kind of prism that you have. Now I want you to think of this as if we take the base off, and we can find the area of just that base. Now, if I take that base off the top and I stacked a whole bunch of bases on top of each other, eventually it would look just like our prism. And so that is exactly how we find the volume. We find the area of the base, and then we're going to stack all those bases together, and that would be the height in between our parallel bases, and that would give us the volume. Okay, so think of it as slices of the base all stacked up until you get a solid shape. So the volume of a prism is big B. Now the big B stands for the area of your base. And the reason why we put it as a big B is because our bases can be anything, a hexagon, a pentagon, a square, a triangle. So first you have to identify what the base is and find the area of it. Then the big H isn't the height of your base, it's the height between your bases. That's how many slices we've stacked up. So remember, if you're going to use these equations, you need to know what they mean. And remember, height is always perpendicular. So it's going to be the perpendicular distance between those two parallel bases. All right, so here we have an example here. First of all, what kind of a prism is this? Even though it's sitting on its side, we know the sides are the rectangles, and none of those sides are parallel. So this is a triangular prism, and the bases are the triangles because they are parallel. So first we're going to find the area of our triangle. And we can see here that they have given us the hypotenuse and they have given us the base. They have not given us the height. But we also can see that it's a right triangle. So we're going to use Pythagorean theorem so we can figure out what the height is because we need that for our area. So we're going to set it up. They gave us the A but not the B, and they've given us the hypotenuse, which is a c squared. And when we simplify that down, we're going to get that the height is 15 centimeters. Now, knowing that, we can find the area of our base. And you can see I've kind of highlighted it there. It's a triangle, so it's going to be 1/2 base times height, and that's our base area. So we substitute in the values that we now have, and the area of just one slice, that one triangle slice, is going to be 60 centimeters squared. Now think about it. If I take that one slice and I'm going to stack them all the way up until I hit to the other side and get a nice solid shape, I'd have to stack it up 13 centimeters deep. So what I'm going to do is take that area and multiply it by the perpendicular height between them, 13 centimeters deep, and I will get 780 cubic centimeters. Remember, those are teeny tiny centimeters that are going to fill up that shape. Now, since we are multiplying centimeters times centimeters times centimeters, we're going to get centimeters cubed. And that makes sense because this is a three-dimensional shape and we're fitting three-dimensional cubic units inside. So make sure you're aware of the units. It should be centimeters cubed. All right, now how does that differ from the volume of a pyramid? Well, on my desk there, you're going to see I have some blue shapes. I have a blue cube and I have a blue square pyramid. Now, if you take the bottoms off those shapes, you can see that they have the exact same size of base. They're both squares. You can hold them up next to each other. They're exactly the same. And if you set them down on the table and put a book across the top, you're also going to see that the perpendicular height of the pyramid and the perpendicular height of that cube are exactly the same. So they have the same base area and the same perpendicular height. Next to that, you're going to find a giant container of rice, and this is going to get a little messy. But what I want you to do is I want you to look at that pyramid and estimate how many times can I fill that pyramid with rice to fill up the cube. So down on your notes somewhere, you're going to write down an estimation of how many times it's going to take to fill it up. And then you're going to pause this video and you're going to have a volunteer go up and do it over my desk because it's messy. And you're going to see how many times you fill up that pyramid until it fills up the cube that has the same base dimensions and the same perpendicular height. All right, so some of you guessed 2, some of you guessed 2.5, some of you guessed more or less, but what you found is when you did it physically, it took exactly 3 pyramids to fill up that one cube. And as it turns out, this works every time you have the same perpendicular height and the same base area. So what's the relationship then between a prism and a pyramid? Well, if it takes 3 times to fill up that pyramid to fill up a cube, then I know that the pyramid is 1/3 of the size of the cube. And so that's exactly. So we're going to identify the base and find the base area just like we did with the prism. We're going to identify the perpendicular height between the top and the bottom. We're going to multiply those together and then we're going to divide it by 3. Because if it takes 3 prisms to fill up a cube, then we take the cubic area and divide that by 3 and we get the volume of a pyramid. Okay, so it's always going to be a 1/3 ratio. Remember again, the big B stands for the area of the base. The big H is the perpendicular distance between the top of your pyramid and the base. So that's going to be from the very tip of your pyramid straight down into the center of your pyramid base. Okay, perpendicular from the top to the bottom, not the slanted height, but right up through the middle. All right, so here I have a picture here. Now this is going to be difficult to see, but this is a triangular pyramid. Okay, so the base is a triangle and the lateral sides are also triangles, but they are not the same. You can see that it's a regular pyramid, so that means the sides of the base triangle are 3 by 3 by 3. But that is not necessarily going to be the same as the triangles on the side. In fact, we know it's not because it's a lot taller than 3. And you can see that the tip of the pyramid down to the center of the pyramid, that's going to be 9 inches. So to find the volume of this, we're simply going to find the base area. Now that's a regular triangle, so we're going to have to use that special formula. And that would be the square root of 3 divided by 4 times side squared. Okay, we'll substitute that in. And we get that the area of the base is 9 square root of 3 over 4. Now in your calculator, you would actually put 9 times square root of 3 equals, then divide by 4. If you do 9 times the square root of 3 divided by 4 and then hit the equal sign, what you're really doing is getting the square root of 3/4 and multiplying it by 9. So be careful. Either you need to use parentheses around the 9 and the square root of 3, or you need to force your calculator to do it step by step so that it knows what you want to do. And you're going to get this big long decimal in your calculator, which you are going to leave in your calculator. Okay? Do not do any intermediate rounding. Or you can just simply leave it as 9 square root 3 over 4 and substitute it back into the equation. So now we have 1/3 times the base area, which we just found out, multiplied by the perpendicular height, which is 9. Okay, at this point, you'll already have the decimal in your calculator, or you would write 81 times the square root of 3 equals, and then divide by 12. If you've done it correctly, you should have 11.69 inches cubed. Now, on your quiz and test, I'm going to ask you to round to the 10th. So that would be 11.7. We don't do any rounding until the very end. And of course, our units are going to be inches cubed. All right, now this one here is tricky. So here I have a square pyramid. I know it's a square because it's marked, all the sides are the same, so it's regular. I've been given that one side of that square is 16. So finding the area of the square, that's pretty easy. But it's given me the distance along the side. It's given me the distance from the tip of the pyramid down to the center of the side. That is not what I need. I need the perpendicular height. But if I take a look at this, I can use Pythagorean to figure it out. So if I drew my perpendicular height down to the center of my pyramid, and then I went over from the side, I would have a right triangle. Okay, so my perpendicular height is that black line. The red line is that slanted height that they've given me, which is 10. And now that blue space right there is 8 because it's going to the center of my square. And we know that since the side is 16, that the center would be 8 centimeters, so half of that distance. So now I have a nice little triangle there. It's a right triangle because I know it's the perpendicular height, and I can set up Pythagorean. Okay, and we are really lucky this time. We got a nice Pythagorean triple, which is super nice. And so we get that the perpendicular height is 6 centimeters. All right, so now all we got to do is use our formula for volume, find the area of the square, multiply that by the perpendicular height, which we just found was 6, and then divide it by 3 because it is a pyramid. Now what that means is that each slice starts big and gets smaller and smaller and smaller and smaller. Third smaller every time until we get to the point at the top. That's also why the third works. We get it in our calculator and we're going to get 512 centimeters cubed. Make sure that you are getting the same numbers on your calculator. If not, raise your hand and let's figure out what you're doing incorrectly, because the reason why most students get this wrong is not because they don't know the formula or what to plug in. It's simply because they're having calculator problems. All right, this last problem is an honors problem. If you're an honors student, you're going to go ahead and try this out. If you're not, you're going to go ahead and start the homework then tonight, which is going to be finding the volume of prisms and pyramids. For my honors students, what I have here is a cube, and I've carved out of it a pyramid in the center, so it's hollow in the center. So to find the volume, I'm going to find the volume of the whole cube, and I'm going to divide out that pyramid volume in the center. So you can think about how that would work out if it was a square prism and I'm carving out a cube. You can figure out those ratios. We're also going to figure out mathematically, so go ahead and try it, and then I'm going to come back and reveal the answer. All right, so let's reveal the answer and see how we've done. You should have had 83.3 repeated millimeters cubed. All right, guys, let's see how you do in tonight's homework.